Good afternoon, YouTube. Peace in, everybody. What's up? So we're up to part number 4 of this current little series here. So we're doing the hardest problems from grade 7. Again, I'm sourcing this from the New York State test over results from about a decade. So welcome everybody joining. If you're catching on this replay, welcome as well. What I'm going to do is I'm going to not do so much of the banter up front this time and just jump in. Just want to say I'm Greg from Greg's Tutoring, NYC. Welcome. Hopefully everybody's all right. Please like and subscribe. Let me just make sure we're going okay here, that the stream is live. What I'm going to do is I'm going to not do. All right, it seems to be. So let me just jump in here then. So we're taking an assortment of hard questions from the New York State test from the past 10 years that most kids made a mistake on. So I actually checked because I know New York City has like 60 to 80,000 kids per grade. It seems like New York State has like 200,000 kids per grade. So this is 200,000 kids took this each year, give or take, because everybody doesn't take it, but the number fluctuates from like 170 to 220. So on average, about 200,000 kids take this a year, and there's 10 years worth. So there's enough to kind of say enough kids are getting these wrong. Let me just make sure my tablet's good. Okay, there we go. All right, so let's jump into number 10. Let me try to get a chat going on my phone so I don't have to keep opening tabs and switching back and forth. All right, there we go. All right, so we're going to jump into the first question. A number n is multiplied by minus 5/8. The product is minus 0.4. What is the value of n? So we can map that just straight into the math. It says the number n is multiplied by minus 5/8. And the product is minus 0.4. Okay, do you see that mapping? We could also flip this around. We could have just made it minus 5/8 n, right? Equals the 0.4. Okay, since we have a fraction here, wait, I got some dots thrown in here for some reason. Not sure where those came from, but let's get rid of them just so. Whoops, that dot belonged there. So what we want to do is take this and map it into a fraction. So we can have that's equal to 4/10 then. And this was a minus, and that's a minus. Okay, so what we want to do is get n by itself, right? We want to end up eventually having it say n equals something. So one way to do that is to multiply the left-hand side by the reciprocal, right? So if I multiply that by 8/5, in fact, minus 8/5, the 5s will cancel, the 8s will cancel, and the minus minus becomes a plus. So we only end up with n. So we do the left-hand side of an algebraic equation, we do the right-hand side to it as well. Okay, so if we multiply this by minus 8/5, we're going to multiply this by minus 8/5. And we can see that since the left-hand side is already n, whatever we end up with here, we're done with. So if we want, we can make this 40/50ths, right? If we want. Or, sorry, 32/50ths. 8 times 4 is 32. And a minus times a minus, so minus 4 times minus 8 is 32. And 10 times 5 is 50. Okay? and that simplifies to 16/25. Okay, we could have also canceled out here. So 2 goes into 10 5 times, and 2 goes into -8 -4 times. And that would have given us the same answer. So in that case, we would have had 5 times 5 is 25, and then -4 times -4 is plus 16. So we still would have gotten the same answer. Okay, so what I'm going to do is, let me shift this up slightly. I want to get some white space out of here. Let me erase what we have here. No, let me just do this over here. So we had, I'm going to show kind of an alternate way of solving this, because some kids were taught different ways. And this way is neither better nor worse. So we originally started out with -5/8. N equals the -0.4. Okay, now some of you are unfamiliar with this reciprocal technique I used, right? The goal was to just get n by itself over here, all right? So what I did was I multiplied by its reciprocal. 5/8, I multiplied it by 8/5. In this case, it was minus, so I kept the sign. So the 2 minuses canceled out, so we only had n at the end. There was an alternate way to do this. The way to get n by itself is to divide both sides by -5/8. Okay, so you can't see that too well there, but it's -5/8 n divided by -5/8. So I did do the left-hand side, I have to do the right-hand side. So I'm going to divide this also by -5/8. Okay, what's good here is this 5/8 and this 5/8 cancel themselves out. So again, we're left with n equals here. And look at what we have on this side. We have 0.4. We have -0.4, so that's equal to -0.4 divided by, if we write it longhand, -5/8. Okay, if we map the 0.4 into 4/10, we have -4/10. Okay, if you remember, if we take this, division by a fraction is the same as multiplication by its reciprocal. Okay, that turns out to be exactly this right here. This part right here. So these two are the same. We got -4/10 times -8/5. So both ways work. This way uses the reciprocal, and this way uses the whole fraction. Okay? Turns out you can see they're both mathematically equivalent. So you have a way to double check this. You also have a way to think problems through differently. All right? Key in all the scenarios is making sure you maintain this minus sign there and that minus sign there. So remember, a plus times a plus is a plus, a minus times a plus is a minus times a plus is a minus, a plus times a minus is a minus, and a minus times a minus is a plus. Okay, I think I said one line there twice. So just to be clear, a plus times a plus is equal to plus. Okay, a minus times a plus is a minus. Okay, a plus times a minus is a minus, and then a minus times a minus is a plus. Okay, this, you can memorize this. I just like to think when the signs are the same, it's always a plus. So plus times a plus is a plus, and a minus times a minus times a plus. So if the signs are the same, it's a plus. Otherwise, it's a minus. This is not, there's only 4 things at most you have to remember here. So, and this is about multiplication. We're not talking about any other operation, and division as well, by the way. But we're not talking about plus and minus. We're not talking about exponents. We're not talking about square root. They all run under their own rules. Okay, so there we go for that question. Let me just make sure we're still running live. Yeah, we seem to be. All right, so let me go on to the next question. By the way, we're going to run about an hour here, or until I just get tired or whatever. There's no end goal, so to speak. Oh, wait a second. I think I just skipped a problem there. No, I didn't. Sorry. All right, so 14 is a slight doozy, as many of these are. That's why they're tricky and so on. Wait, it's not fitting on the screen. Give me 1 second. All right, that should be on the screen now. We don't care about the question number on this. So. All right, so a company orders 10 box lunches for $74.50. Halt. So I'm just going to think, again, I'm just ripping apart what I'm seeing here. I might say how many lunches were there? There were 10. What was the total price? It was $74.50. I might even ask myself, okay, give me 1 second because it's saying the YouTube failed. So let's see if we got a stream here going still. Don't know what's wrong. I might say how many lunches were there were 10. Okay, I'm not sure what happened there, but it told me the stream on my phone was dead. Okay, so I think you can see that each lunch, if we do $74.50 divided by 10, was $7.45 each. So we can ask ourselves stuff like that. So each box lunch costs the same amount. So that confirms they weren't even different price things. So they're each $7.45 each. Okay, we don't know what the question is here, but let's see. So which equation represents the proportional relationship between y, the total number of box lunches, and x, the number of box lunches? Okay, so personally, I would use N and P. So for instance, the total price over the number of box lunches. Okay, so I would get $74.50 over 10, right? I think we can all see that. Okay, they're not calling it P and N, they're calling it X and Y, which kind of makes it a little more confusing. So let me do with my personal conceptual model and map it onto what they're saying. So they're saying Y is the total cost of the boxes. So they're calling this Y. And X is the number of box lunches. Okay? So at this point, we can kind of ignore this, even though that was our original model, so to speak. Okay? If nothing else, you still have the words. I personally would do it this way. I would put the 2 things there. I might just put an arrow on here saying to avoid that or something. I might actually show where I'm showing my work. So they want to know which equation. So they don't. So if you remember, I said this was equal to $7.45. They don't want to know $7.45. They want to know what the equation will be. Well, these 2 things here is my equation. The problem is they don't map. what it says in the ABCD choices. So I have to somehow move my situation into their situation. I have to do some mapping somehow, right? So we're going to have y over x equals 7450 over 10. Okay? I can do a few things here. I can flip the both of them. So first of all, none of them matches what I wrote. I can flip them and do x over y equals 10 over 7450. Okay? So that's still proportional. That's still in proportion. So now I have the number of boxes to the price is to the number of boxes over the actual price, right? So the actual number of boxes. So we're still cool here, right? So none of those matches what I did there. In fact, the denominators are always x and y. So we can kind of flip that too if we want. Since I can do the cross product here, there's another proportion I can do by just flipping these two. So I can do 7450 is to y as 10 is to x. And the reason that's true is because if I actually did the cross product, I would get 7450 times x equals 10y. And if I did the cross product of this thing here, I would get that same equation. So what we're trying to do is just manipulate these around until we find the form that looks like theirs. Okay? So it turns out that there's really still not one. So A kind of looks like mine, except I have 10y here and 7450y. They have 7.45. So, what if I divide both sides by 10? Okay, if I do that, I end up getting A. All right? And it turns out that if we look at B, it should be, when we have x and y as the denominators, 10 should be over y, but in this case it's over x. So B is no good. And C is 7450, x equals y, but it threw away this 10 here. So that's no good. Okay. And then D has the same problem that B had, which is that the 10 should be over the y. Plus the difference between the B and the D is the 7.45 and the 74.5. So B kind of has two problems and D has one problem. So at the end of the day, the answer is A. All right. So they're not actually asking you to solve it. And since it doesn't have to say, A could have also said y equals 7.45x. That's also valid, except it wasn't one of the choices they gave. So the symbol by itself, it can be on the left-hand side or the right-hand side. It's still an equation, right? It's still an equation, all right? So a lot of kids got this question wrong. So if anybody has any questions, let me check if this what's going on in the chat there. Yep, there's a bunch of people in the chat. Anybody has any questions about this? Because this is kind of a hard problem in a way. Not only do you have to understand the words and set up the original proportion properly, but then you have to go cherry picking on all these permutations of the proportion to find one that force fits into theirs. And this happens a lot on these where they ask basically for a formula or an equation or an expression. The choices they give is not necessarily the expression you would have given if you simplified it. Okay? All right, let me see some of the others here. Okay, so this kind of combines a whole bunch of different situations. So we have a third and a sixth being subtracted, and then a quarter fraction at the bottom. So just take this as PEMDAS. It's basically saying, because we can rewrite this to be this here, A minus B divided by C. So in this case, the 3/4 would be the C, A would be the 2/3, and 5/6 would be the B. So really what we want to do is convert this 2/3 into sixths. So I think you can all see that that's 4/6. Right, if we multiply the numerator and denominator by that. So basically when you get 4/6 minus 5/6, so when you get minus 1/6, then we're going to divide it by 3/4. And as the running theme keeps going here, division by a fraction is the same as multiplication by its reciprocal. Okay, so let me just put them next to each other. So we have minus 1/6 times positive 4/3. So we can just go straight up here and get 4/18. 6 times 3 is 18. This was a 3. Okay, or we could just go in here. Then this would be minus, because that was a minus. And get minus 2/9, which is A. We could have also canceled. 2 goes into 4 twice, and 2 goes into 6 3 times. So we get 1 times 2 at the top, right? That was a 9. And 3 times 3 at the bottom, and the minus sign has to stay in there. All right, so that one wasn't too bad a one. By the way, this kind of problem shows up often enough on actually very hard tests, and it's still there for a reason that kids get tripped up on this too many times. So you guys got to watch out for this. Okay, 21 is another one that seems simplistic, but when you kind of slap it around a little bit, it can start getting a little involved. So the important thing is to either, in this case again, either bring the fraction to a decimal, and that kind of looks hard. We can divide 15s into 8 and probably get some weird number. Let me just fly that up here just so we can see what kind of number that would be. So 8 divided by 15 equals, yeah, it's a weird number there. So we kind of don't really want to be dealing with that. We don't want to divide that by minus 0.35. All right. Plus, the other thing is that all the answers are in fraction form. So both of those things together is kind of a good hint that we want to convert this to a fraction. So we're going to get 8/15 divided by 35 over 100. By the way, some of you guys have problems deciding what the denominator should be. It's decimal, so you have tenths, hundredths, and that's it. That's how you know what the denominator is. So we have division by a fraction, so we're going to get multiplication by its reciprocal. Okay, and that's going to be 8/15. So we can multiply the numerators and get 800. The denominator and get some number, 15 times 35. What I like to do, though, is to try to find out what cancels into what. So I can see here that this 5 can go into 15, 35, and 100. So I'm going to try to shoot to try to get rid of the 15 first. So 5 goes into 15 3 times. And that means I'm going to shoot for a numerator. So that's going to be 20. Okay, and by the way, I'm allowed to do that because if I have A over B times C over D, I think you'd all agree that's the same as A times C over B times D. And at that point, it should leap out at you that you can cancel B into C and so on. Because if nothing else, if you actually multiplied A times C and got, X, and you multiplied B times D and got Y, there was probably something you could simplify in some cases. So if you could simplify it, it means either A and D had a common factor, or B and C had a common factor, or A and B did, or C and D did, right? So that's why this can work. So if we come back to this, the 5 went into 15 3 times, and the 5 went to 120 times. So we notice it's still a divisor. 5 can go into here 7 times, and 5 can go into here 4 times. Okay, and if we multiply that out, and there's a minus sign here still, so we get 8 times 4 is minus 32, and 7 times 3 is 21, so we get B. Okay, in this case, they don't want to simplify. They're leaving it top heavy. A lot of you used to just automatically writing equals minus 1 and something or other, right? This would be 21, so this would be what, 11? Minus 1, 11, 21s, right? They're not asking for that form. So always, it's good to solve a problem by putting your hand over the answer choices, but on the same note, you could waste some time kind of doing too much. All right. So this is kind of straight up, but again, a lot of kids are getting these wrong. So these are common grade 7 problems. And it's easy to say, oh, the smart kids are not doing this and so on. I work with a lot of smart kids. I work with kids across all ranges of social, economic, wealth, and proficiency. And it's a common issue across everybody. Yes, the more proficient student doesn't do this as much, but it's still a gotcha. And it means you haven't mastered the math completely. And this deals with your numeracy, right? Take things a little step at a time and just pace it out. And as you practice, you'll get proficient. It doesn't mean you're never going to make an error, but you want to reduce these category of what's called silly errors down to the least amount possible. I work with some kids for like the SHSAT, and they could get 10 to 20 questions wrong just on stuff like this. And it's weird because the harder stuff, the harder concepts, they can get. But something as simple as this, they'll kind of mess up. But it means you haven't mastered it. You need to be able to do that. So 22 is kind of along that kind of same lines of this kind of a thing. So it looks kind of simple on the surface. So let's take this thing right here first. So you could probably all see that we need to convert into quarters. So this is the same as 3 and 2/4, right? Because 2/4 is a half. So what I'm going to do is add that to the minus 9 3/4. Because that's how subtraction works if you wanted to. In other words, we're going to get minus 6 is the answer. Like, if it was 3 minus 9, all you guys can see that. So all we're going to do is basically do a subtraction and ignore the sign and then add it back at the end. Right? Sorry, that was a quarter there. Wait, why did I write a half again? Give me 1 second. I can't walk and chew bubblegum at the same time. Let me remove this too, because I said I was going to add them. I'm actually not going to add them. I'm going to subtract them and then add this sign back at the end. So I'm going to get 6 1/4. My handwriting is bad. Bad handwriting. And then I'm going to add the sign back. Okay, so now I'm going to have still drop down to this here. I still needed to divide by the minus 2.5. Okay? So two things should kind of leap out at you based on what we've been kind of saying here. We need to either convert the 6 1/4 into a decimal, and we can do that easy. That's just 6.25. Okay, right? And then that's going to be divided by this minus 2.5. Okay. The other thing to note is that we have a minus divided by a minus. So if we did all that right, A and B should be kicked out. By the way, there's a pattern here. It's minus 2.5 plus 2.5, minus 2.3 plus 2.3. So there's a choice that ends up needing to be made here. Okay, so since we have minus 6.25 divided by minus 2.5, it's a minus divided by a minus. We just went through that. So that's a positive. All right, so what we could do is 2.5 that should have been a 5 divided into, and since it's a minus going into a minus, I'm just not going to ignore the sign. Okay, what I can do is, because I want to move the decimal point over here, so I have 25, I'm going to move it over once here too as well. Okay, so the decimal, whatever the answer is going to be, is there. So 25 goes into 62 twice, that's 50, right? With what? 12 left over. So we get 125. 25 goes into there 5 times, and the answer is D. Okay, so let's solve this with fractions though, because that could have gotten ugly. Wait 1 second, my cursor's freaking out. So if we do it with fractions, we're going to have 6 1/4, right, is the same as 25 fourths. And just to make this clear, I was throwing the minus sign, but let's add it back in. Okay, and we're going to divide that by minus 2.5. But 2.5 is the same as minus 2.5. And that's the same as minus 5/2. Right? So we're going to divide that by minus 5/2, and it's our standard flipping the fraction thing again. We're going to get rid of this, and we're going to multiply it by minus 2/5. this was a 4, right? So 5 goes into 25 5 times. And 2 goes into 2 once and here twice. So that's a 1, that's a 1. This is gone. So we end up with minus 5 halves again. Sorry, the two minuses cancel each other out. So we get 5 halves, which we know was 2.5. All right? So there's enough going on in this problem, so that's 2 different ways to do it, just to make sure you're good. Okay, let me make sure we're still live. Yes, we are. Right, some of these is not the most lively problems ever to be solved, to mankind. Okay, 29 kind of just falls into place with what we've been talking about. So we have which expression represents the product of 3 and this thing here. So what we're trying to do is A times B. Okay, which we can also write as, it's the equivalent to, there's multiple ways to write how multiplication should happen. A, and we can parenthesize the next thing here, right? So this is kind of the form of what they're asking for here. Notice the 3 is the A, and this whole thing here is B. So all we have to do is merge them. It's 3 times 5/4 n plus 1.8. Right? That's the product. Product means multiplication. So which expression represents the product of A, which is the 3, and the parenthesized thing? So I just wrote that out. So nothing matches that. So we have to kind of go through. So this is the distributive property. This is A. And it's a different A than we were talking about here. Remember, this is symbolism. So this is A times B plus C. So we do AB. So we can get 3 times 5/4. So we get 15/4. N plus 1.8 times 3. So a lot of you guys know your multiplication table up to 10 by 10. That's cool. That's nice. And some of you also know it up to 12 by 12. But you should really know it up to 20 by 20. Okay? So 18 times 3 is 54. So 1.8 times 3 is 5.4. By the way, this kind of a thing comes up in a lot of your homeworks. 3 times 17, 3 times 18, 3 times 19. That comes up a lot. And it means you also should know what those 3 answers are. Right? So 3 times 17 is 51. 3 times 18 is 54. 3 times 19 is what? 57. Right? So those are things you guys should have memorized. They come up a lot, including from all your classes from now on as well. So this is stuff you need to know. So what we have is, I now went through that, and I'm still not seeing the answer. So it seems to me that the answer is not A, the answer is not B. D is the only one with the 5.4, but it's a different form. Oh, I wrote this while I was talking. So this is 15/4 times n. Okay. So that still doesn't really help us. So what you have to do is bring that back to a decimal. So how many fourths? So 3 times 4 is 12. And then 13, 14, 15. And this is the same as 3.75, which gives us D then. Okay? So this one isn't too bad. It takes me 5 minutes because I'm explaining every kind of little step here. But the last two are really kind of 10-second problems that you should just zoom through. Remember, don't go too fast though, because remember, these are the problems that most kids got wrong. Okay? And I do mean most kids. Some of these, only 30% of the kids are getting them right. So that means 70% of the kids got them wrong. Okay, so the next one might be slightly weird terminology of you guys. Let me just make sure it's fitting on the screen right. Just squeeze it a little bit there so it fits. Nope, it's still not there. Okay, in some past the past parts of this, especially 1 and 2, I think, there was discussions where something said like 20% off. And depending how the question's worded and so on, it should be clear to you guys that, first of all, percent means over 100. So this 20% is the same as 20 over 100. Okay, and if something's 20% off, that's off from 100% or 1 from its full price. So that means the new price is going to be 100 minus the 20. There's 100%, 100 over 100, 1, which is the full price, minus 20% is going to equal both of these over 100. Is going to equal 80 over 100. So in other words, if something is 20% off, another way to look at it is that it's 80% of the full price. Okay? So I'm mentioning that because this question delves into not exactly going into it that way, but somewhat the reverse of it. So let's try to read the word problem and try to rip it apart, and then look at the answer choices as well. So because it's being presented in a form you kind of may not have seen before, which might be one reason why a lot of kids got this wrong. So the original selling price of a share of a stock was $D. So that's the full price. Somebody paid $D for a share of a stock. The selling price for a share of the same stock at a later date was represented by this expression. Now, what's going on there? So it's 1.15 times 0.095D. And then it says which description could explain what happened to the price of the share of the stock. So if you notice how I went from 100 here, minus the 20, to give us 80. Okay? So in other words, it got smaller. There's a flip side to this too, which is that if it was 20% more, by the way, let me just make sure that's just coming on the screen what I'm writing. No, it's not. Okay. Then we would have 100%, the whole thing, plus the 20%, and that's equal to 120 over 100. By the way, if we simplified this 80 over 100, we get 0.80. And in some cases, that's also, we could talk about that as 0.8. In this case, this is going to be 1.20 or 1.2. So if we use this as kind of a barometer, if you will, we can see that if the percent is less than 100, the price probably went down. And if the percent ends up being greater than 100, it probably went up. Okay? So if we look at the two parts of this 1.15, then let me use different color to talk about those two different parts. So the 0.95 in the red, and I'll change this to another color here, the 1.15. If the original price was D dollars 100%, 100 over 100, and it's now 95, then it seems to me the price went down under the red zone, right? The price went down. I'll just put D there. And if this is 1.15, the price went up. Okay? We don't know what's going to happen with these, and this is a multiplication. This is D times 0.95 times 1.15, right? Use PEMDAS, do your parentheses, 0.95 times D, and then go outer times 1.15. Okay? So now that we kind of understand the yin-yang that's kind of happening here, let's see if we can make sense of the answer choices. So it says, so first of all, it says which could explain. So there could be other explanations. We're just looking for the choice that could be an explanation for why these two numbers are appearing this way. Now that we understand what the percent changes can affect what the numbers look like. So it says the price decreased by 5%. Well, it seems to me that 5%, let's see, where can I write this? 5% is equal to 0.0, that's tenths, 5 hundredths. So if I do 100% minus 0.05, I'm going to get 0.95. So it says the price decreased by 5%. Yeah, if you get at 1 and you subtract 0.05, which is 5%, you're going to get 0.95. So that represents the red right here, where I labeled G. Okay? And then it increased by 0.15. So a lot of this will be a gotcha to you guys. This turns out to be wrong. So this part here is true, and this is false. I'm going to tell you why it's false in 1 second. Okay? Then it says the price decreased by 95%. Well, that doesn't work, so that's fail. And then increase, so this is still a foul because it's still the same thing. So both of these are a foul. So A is no good, and B is no good. Okay, if the price decreased by 95%, that 0.95 would have been 0.05. Right? It'd be 1 minus 0.95. All right, so it's not that. So C says the price decreased by 5%. It did. And then increased by 15%. So if I have 1 plus 15%, which is 15 over 100, okay, we know 1 is 100 over 100. I'm going to get 115 over 100. And that's equal to 1.15, which is exactly what we said the U was. Okay, so C checks out. It went 1 minus 0.05 is 0.95, and 1 plus 15 is 1.15. Okay, and then D is no good. The price didn't decrease by that, although the price did, so this is false plus true. Okay, the reason A gets a lot of you guys is a lot of you think this is the same as that. Okay, again, this means 15 over 100. And this means 0.15 over 100. Right? 0.15 over 100. 0.15 over 100 is 0.0015. Okay? That has nothing to do with this problem. All right? So that's why the answer is C. All right? So this is kind of a doozy. So I think the gotcha of a lot of you guys is that you've never seen anything like this necessarily. But what you need to start doing is piecing together, and this is actually a good question that makes it hard. This is one where even a kid who went to a good middle school and is proficient and so on can still move up. Because what you want to do is take what you know, not just your knowledge, but start using it in some way in cases of novel problems that you need to solve. Think about the problem critically, like what's going on here, what is this expression doing, what's happening, do all the kind of legwork I did with the percents just to try to start comprehending it. And especially now that you've seen it, so the next time you see it, it shouldn't be that big of a problem. Might still be a gotcha too, so be careful, because there's still stuff like this 0.15% thing. That's still, it's easy to think that's 15%. It's not. 15% is 15%, not 0.15%, right? And 0.15 is 15%, so be careful, right? 0.15 is 15%, because 0.15 means 15 over 100, and so does 15%, right? 0.15 is equal to 15%. 0.15 is equal to 15 over 100, and that's equal to 15%. Notice right here, there is no decimal point. So that means 0.15% can't be equal to 15%, right? Since I did the decimal point there already, that's not equal to 15%, right? 15% is not equal to 0.15%. All right, and then this is the last one we're going to do. It's also kind of a doozy. Let me just make sure that this is showing on the screen properly. Yeah. So I like to look at the illustrations first. And I actually computed this so I don't goof this up. Where did I put that? Here it is. Because there's too many numbers flying around here. So I computed this beforehand. So let's just look at it conceptually. So we have, I like to look at illustrations first. All right, so we have something is on discount, it's claiming, right? And you can buy 2 shirts, get a 3rd shirt off 50%. So that means if you buy 2 shirts, if you buy 1 shirt, you're going to pay full price. Okay? If you buy 2 shirts, you're going to pay full price again. Okay, and if you buy a 3rd shirt, you're going to get 50% off. So another way to look at that is you're going to pay half price. You're going to pay full price divided by 2. Okay? And we don't know if we need to use this or not yet, but that's 2.5 times. This is the same as 2.5 or 2.5 of the full price. So if you buy 3 shirts, you're paying 2.5 of that full price. Okay? So there's really nothing else in the illustration. So let's go back to the words. Remember to go back to that and read that. A clothing store used the sign shown below to advertise a discount on shirts. Okay, so there's not really too much being communicated there, but that's okay. So Kai wants to buy 3 shirts. So somebody is going to do that, which were originally priced $49.96 each. Okay, so since it said each, it's not saying the price of all the 3 shirts together is the $49. It's saying the 3 of them are. Sorry, that only each one is. Okay, so I'm gonna put a bar there, which is my mental way to stop, and I'm gonna look at this and say, well, he bought the 3 shirts, so it seems to me that he paid $49.96. He paid another $49.96. Ah, I don't know why that's coming out written so horribly. And then he paid half of that. Okay, so if we do 2 into 49.96, what I'm going to do is I'm just going to put a 2 over here and kind of do it, because we're going to tally these 3 numbers up. So 2 goes into 4 twice. 2 goes into 9 4 times. Okay, we're going to have 1 left over, so 2 goes into 19 8 times. No, it goes into there 9 times. So that's 18 with 1 left over. And then we get an 8. So this was only here to do the division by 2, so we could follow it. So what we're going to do is add the 3 of these up. Okay, when we add those up, we get 124.90. Okay, so the store will discount the price of the 3rd shirt. Okay, so we already went through that. We already calculated that. And then apply a 7.1% tax to the total cost. So this is where the problem gets nasty super fast. Okay, including the tax, what will be the mean cost of each shirt? So basically what they're saying is they're going to take this price, let's call this P. Okay, it's saying what they're going to do is take 7.1% of P, right? Add it back in. So what we have is 7.1 adding back onto it, right? So we're going to have 107.1%. right? It's the full price of whatever this was, the 124.90 plus 7% more, right? So there's a couple ways to do this. We can get 7% of 124.90 and add whatever that number is back into 124.90. And then at some point, we're going to do a division by 3. So either we do the 7.1% and add it back in, or we do 107.1% of 124.90. Okay? So it turns out, since there's a multiplication and a division, what I did was I did the division first. So I divided 3 into this here, because it turns out I'm using the commutative property of multiplication. So 3 goes into here 4 times. 3 goes into 1 with 1 left over. 3 goes into what, 6 times? And then I believe we get one more time here. So we get a repeating 3. So this turns out to be my mean cost of a shirt without the tax. So then what I did was I added the tax in. So when you do the 4163 times the tax, you're going to end up getting C. All right. By the way, we can kind of estimate some of this too. If the price of the shirt was $49.96, it's about $50. A second shirt is $100. A third shirt is $25. So we have $125, right? Okay. It's saying it's 7%. 10% is about $12. Okay. That means 5% is about $6. But this is 7. So it's about $8 on top of it. Okay, so if we add 8 to that, when you get 133, okay, and if we divide that by 3, we should also still get the same answer. And by the way, you should see that A and D completely rule out, because they're, no matter how we approach this, they're really kind of out there. All right, so that's the kind of things you want to do. Let me tell you some of the numbers here. So when I did, let's see, where is some of this here? So when I did the 124.90, and I multiplied that by the 107.1 to get the percent, I ended up getting $133.76. When you divide that by 3, you get the 44.5893, which turns out to be choice C there. So what I'm doing is telling you the numbers in case you did it the other way. And I don't see where I wrote down some of this other stuff here as well, but anyway, actually using the numbers and then doing the estimation is helpful. Let me just see if the next one's short. If it is, I'll do it. If not, we're done. We're done. Okay, yeah, let me slip this one last one in, I guess. Okay, let me just make sure it's showing on the screen. Yeah, so wallpaper was applied to one rectangular wall of a large room. Oh, actually, we want to look at the illustration first. So we have something that's about 40 times 25. Okay, so it's about 40 times 25. So if we were to just trying to get a calculation of that, 40 times 25 equals, so we get 1,000. Okay, you guys should know that, because we can take 25 times 4 and get 100 and add that extra 0. So this is about 1,000 square feet. We don't know if they're going to ask us this. We're just doing this super fast. And on the real test, I may not actually even decide to calculate this. So this is the 1,000 square feet. Most likely it's an area question though, so that's kind of where I'm coming from here on it. Okay. Wallpaper was applied to one rectangular wall of a large room. Because nothing else happening here, so I'm done with the illustration. Wallpaper was applied to one rectangular wall of a large room. Dimensions of the wall shown below. Cool. If the total cost of the wallpaper was $771.12, a nice ugly number, what was the cost in dollars per square foot? All right. So what you really need to do is the 42 times the 25, right? $25.5. Okay, that is literally equal to, do I have that anywhere? I don't know if I printed that paper out. La, da, 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 da. Yes, I did. Let me do it on the calculator because I can't read my writing. I have a bunch of numbers flying all over the place. So 42 times 25.5. It's 1071. That's what I thought I wrote, but I wasn't sure. Okay, so that's the square feet. So what we need to do is the dollars per square foot. So that's what we're looking for, dollars per square foot. I'm just going to put a little T2 here. So that means we're looking for 771 dot 12 over the 1071. Okay, which is definitely nasty territory. So if we do it on the calculator, we get, where is it? 771.12 divided by 1071, and that's equal to the 72 cents exactly. So that gives us the B there. Okay, we could have estimated this as well, because if you go with the 1,000 here and the 771, all we have to do is move the decimal point twice. None of the choices are even near 70 cents, right? This is double it really, and this is 10 cents less. So it's pretty safe to assume that we could have just done the 40 times the 25, so this is 1,000 square feet, moved the decimal point over twice, three times, right? Times 10, times 100, times 1,000. So for each zero, move it over to the left, and just said it was 70 something cents, and be done with it. All right, guys. All right, I'll continue on another time. Please like and subscribe, please. Right? Let's do this. Get rid of the calculator there, and hopefully everybody has a nice day. I'm exhausted at this point, so peace out, y'all, and hopefully this is helpful for you guys. Take it easy and have a nice day. Bye.